Bismillahirrahmanirrahim. I'm going to explain the basic forecasting using Eviews. The variables which I will work on: the payroll, which represents the employment levels and thousands of employees. The source was from Bureau of Labor Statistics. The second variable is the industrial production. We've got the index levels from the Board of Governors of the Federal Reserve and the Institute for Supply Management Manufacturing Index. We've got the index level and the source from St. Louis Fed database. Finally, we have taken the table 3M, 3 months US Treasury rate, and the source from the Board of Governors of the Federal Reserve. As you see, the spreadsheet produced here shows the data series at the end of the work file range, and we know that the historical data are available for all data series up until March 2013. From 2013, month 4, until the end of the work file range, we have provided forecasts for series IB, ISM, tables 3 months, and we will create a few equations to forecast the payroll series using Eviews. Let's take our example for forecasting with exogenous variables. Suppose we want to forecast the level of non-farm payroll employment for the period start from 2014 April to 2014 December. To accomplish this task, we first need to specify and estimate a model. Let's model the payroll level as a linear function of a time, trend, and seasonal factors. In our example, we type in the command window ls payroll, see a trend, expand, month, drop first, and we press enter. But we should note that the command a expand a month create 12 dummy variables, one for each month of the year. These are the seasonal factors. Because we have included a constant, we need to exclude one of the dummy variables in order not to fall in the dummy variable trap. In our case, we have chosen to exclude January by using the option drop first. We can drop second, we can drop third, we can drop fourth, but we selected to drop first from the 12 month during our period. When we look at the estimation output, we note that Eviews has estimated the model over the period from 1960 January to 2013 March, for which we have payroll data. Also, we plot the actual and fitted values of the model by pressing view actual fitted residual graph, and this is easy and we understand this very well. Now we need to produce a forecast for the payroll series based on our model. For this, all we have to do is press the forecast button in the equation toolbar. Once we press the forecast button, the forecast dialog box will open up. Under series name, we specify a name for the forecast series. Give it a name, and Eviews will suggest a name, for example payroll F, but the series will be overwritten every time a new model is estimated. So let's save our series as equation number 1 F, for example. And the forecast sample, we select the sample over which the forecast will be carried out, and here we type 2013 month 4 at last. We check insert actual for output of the sample observations. Under method, we should notice that Eviews indicates that static forecast because there is no dynamics in the equation, and we will talk about that later on inshallah. Under output, we select forecast and forecast evaluation. That's okay. What we see here is the forecast output is shown, and we notice that the Eviews shows the series equation series which we called Q1F over the forecast sample together with two standard errors. You see the two standard errors bands. Also, we note that there is no new series equation 1F saved in the work file. Let's open the series and the original payroll series as a group together to see and inspect them more closely. We noted that the two series are identical when looking at the historical data. Why? Because we elected to check the box insert actuals for output sample observations. And this gives instruction to Eviews to use actual payroll data for the output of forecast sample. How does Eviews compute these values? Let's recall that the explanatory variables in this model are a trend and seasonal factors. Eviews computes the forecast for April 2013 as follows. A trend April 13 will equal 639, and the trend coefficient will equal 144.4909, and a month equal 4. A month coefficient will equal 1476.381, and the constant will equal 51,730.04. The equation 1F April 2013 will equal, the constant is 51,730 plus 144.49 times 639 plus 1476.381 times 1, only for April. What would happen if we set the forecast sample to be the entire range of the work file? Let's see. We press the forecast button, and under the series name, we name the new forecast series as, say for example, equation 1 F3, and all other options we will leave it as it is, as we made before. What we did, we select graph, forecast and forecast evaluation, and we check insert actuals for out of sample observations, and the forecast sample, we set sample to the entire work file range from 1960 month 1 to 2014 month 12, and we click OK. Now we need to make some evaluation for forecast. The forecast output clarifies that Eviews has computed equation 1 F3 and its standard error bands over the entire sample. And we notice also that in addition to the graph, Eviews has produced a small table. This is the forecast evaluation table. Although we had checked the forecast evaluation box in the previous illustrations, Eviews was unable to produce an output when the forecast sample was set for future periods 2013-04 to 2014-012. Why? Because Eviews could not check how well the forecasting model works, since the payroll data beyond the 2013 month 3 is missing, and we would have to wait until future date when payroll data becomes available in order to compare our forecasts with what actually happens. Anyway, when we set the forecast sample to the entire work file range, or a sample that includes actual historical data, it's possible to check for forecast accuracy. Eviews compares the the predicted values from the model over the period 1960 months 1 to 2013 month 3 to the actual, of course, to actual data, and compute the forecast evaluation table. Also, we can inspect in more detail the difference between the actual payroll series and the forecasted equation number 1 F3. We can open them as a group and plot them together. As seen from the graph, values differ over historical range from 1960 month 1 to 2013 month 3. Why? Because equation 1 F3 series comes from the fitted values of equation 1, whereas the payroll series contains actual data. Of course, the equation 1 F3 series is also longer. Why? Because it includes the future predicted values over the period from 2013 month 4 to 2014 month 12. Thank you.